Well, sometimes you don't get a chance to fit all the stories into a show. And one of them from last year, I'm very excited to bring you now on the new format of the Changemaker show to Sarah's Country every Wednesday. And this is where scientists have discovered an extensive body of fresh water off the Canterbury coast between Timaru and Ashburton. NIWA's marine geologist Dr. Joshu Mountjoy says the discovery is one of the few times a significant offshore aquifer has been located around the world and may lead to a new freshwater resource for the region. And he joins us now. This is pretty exciting stuff, Joshu. Can I just start by asking, how does one end up in a research field like this?
Yeah, I started working on land and working on large landslides and commercial developments, and then went into research, did my PhD in marine geology, so studying the seafloor and how it's formed and all of the techniques we use to study the ocean floor. And then more recently, and really only in the last few years, one of the kind of emerging and exciting fields has been trying to understand the connection between fresh groundwater onshore and then what happens beyond the coastline, because of course the coastline is not the total boundary for the onshore geology. It continues offshore, and so that if we've got large aquifers onshore, there can potentially be an offshore component to those as well.
Aquifers in general are commonly misunderstood.
Yep, I would say so. I'm not a hydrogeologist, and people who study in that area have a great understanding of aquifers, but often don't really think about that offshore component. So I'm sort of bridging across that.
Yeah, and so this particular reservoir that has been discovered is only 20 metres below the sea floor. That seems really shallow.
Yeah. Well, yep, 20 metres is a fair way, I guess. It's pretty important to have the context for a system like this. We go through, going to step back to some quite big picture stuff here. We go through these glacial ice ages. Everyone's aware of those to some degree. What it means is that 20,000 years ago, we were in the peak of one of these ice ages, and a lot of the seawater was locked up in ice at the poles especially, but all around the world. And it means that the sea level was 120 metres lower than it is today. So what that means is that the coastline is way further offshore than it currently is. And so in the Canterbury situation off Timaru and that kind of area, the Canterbury Bight, the coastline is actually up to 50 kilometres further offshore than it is today. And so the coastal plain is way, way bigger. So at that point, you've got rivers crossing that whole area. They're putting down their deposits, gravel and silt and sand like they do today onshore in the Canterbury Plains. And it's raining on that area, of course. And so you have the development of your groundwater systems and surface water systems there. And then once the sea level starts to rise, and that finished about 7,000 years ago, then you start to deposit your marine muds and everything over the top of that, and that kind of seals it and locks in the coarser grained gravels and sands and so forth that were terrestrial deposits, we say, things that were put down by rivers. And then you have that process repeating, and the glacial cycles happen about every 100,000 years. And so over time, you build up the sequence of sediments offshore. And this is what we've been focusing on. And so that 20 metres can represent actually quite a lot of time or material that can be the finer grained material that creates a divide between the seawater and any potential fresher water underneath. And it's quite important to get that point across here, is that we're not necessarily got something that we could pump out of the ground and drink. Often these freshwater reserves offshore can be quite brackish and sort of be somewhere in between total freshwater and seawater. But we've got indications here that this has got a reasonably low salinity.
Yeah, so when it comes to the discovery and then, of course, measuring things, like you said, salinity, how do you go about doing that?
Yeah, so it's definitely tricky. In this case, it was a kind of a chance discovery. There was some scientific drilling happening off the coast of Timaru, and they found they were looking at something completely different, at the sort of sedimentary cycles related to glaciations, but they always do as much analysis on those core samples as they can. And so they were taking the pore water and they draw it out of the cores. So in between the grains of sediment, you've got a bit of water locked up in there, and analysing that for a whole lot of things. And one of those is salinity, and they found low salinity spike about 50 metres below the seafloor in that drill hole. And so then that kind of drove this whole research. It was by a collaborator I've had in Europe. He's Maltese, and he got some European funding to come and study this offshore Canterbury, because it's one of the few places where this has really been identified, and it's an ideal place to study it. We've been working together for a long time, and in New Zealand we have some good equipment that we could offer to join together this collaboration. The key thing about the salinity is using electrical methods. And so we look at the resistivity of the sediments, the electrical resistivity or conductivity. They're just the inverse of the same thing. And if you've got fresh water, it's less electrically conductive than salt water. And so you can see areas within the seafloor sediments where that electrical conductivity changes, and that gives you some idea of how saline it is.
Interesting. And the fact is also is the volume that's there, 2,000 cubic kilometres of water, equivalent to half the volume of groundwater across Canterbury. Naturally, the first thing that I'm sure the discovery was, how do we tap into it? Do we need to tap into it? For what reasons? What sort of come out of publishing your research?
Yeah, absolutely. I guess we've got quite a long way to go to prove that this is, the scale and the salinity of what's been interpreted from the geophysical survey that we've done. And so we are proposing further drilling and things like that to go and take it further. But nonetheless, we have a good idea of what's happening. And yes, there's definitely significant implications for society here. There's two things really that are possible. In this case, it looks like this groundwater reservoir is quite old, and it's not necessarily directly connected to what's happening onshore. So it's not like the water that's flowing underneath the Canterbury Plains is just continuing out offshore and becoming part of this. It looks like this reservoir is quite isolated, and so it's probably quite old. And so it means it's potentially a non-renewable resource, and so if you started extracting it, it's not going to be replenished for 100,000 years or something, which is out of our time frame. But nonetheless, it's there, and if it's reasonably close to fresh water, then it could definitely be something that could be used. And so you would want to do a lot more work to understand it. And that is offshore Canterbury, but that same model of groundwater probably applies all the way along the Canterbury coast, and also in other places such as Hawke's Bay and other areas on the east coast of the North Island and the northern part of the South Island as well. And we've been looking at the potential for offshore groundwater resources all around New Zealand, and working on a publication on that with Leanne Morgan from the University of Canterbury. But the second part of it, and probably the more important part for New Zealand, I think, is that if we have systems that extend onshore to offshore, and they are connected so that they're recharging the offshore part of that from onshore. And a great example of this is in Wellington. The Waifatu aquifer is used for 70% of Wellington's drinking water, I think. We know that extends offshore. There's a marine borehole near Soames Island where fresh water is taken out, and they carefully monitor when they're taking water in Seaview near the coast how much they're taking, so that they don't start drawing the offshore part of it and drawing in the seawater. So in Wellington, we have a good idea of how far the groundwater extends offshore, and we can manage that really carefully. But in many places, we have pretty much zero information on how far offshore the freshwater extends. So you can imagine a situation where you've got near coastal groundwater bores and you're extracting water. It's managed by local government, But we don't know how far offshore the freshwater extends. And so if you're taking freshwater near the coast, you could actually be drawing that freshwater from offshore. And in many cases, we probably are. We have pretty much no examples around New Zealand of coastal groundwater salinisation due to over-extraction. But we don't know how far away that might be. And so potentially we are drawing that offshore water, and then one day the saline part of that might arrive at the coast, at which point it's definitely too late. And so in terms of trying to understand these systems, I see the most important part of it is knowledge of how far offshore that is so that we can make sure we manage these for the long term.
Golly gosh, you have such an important role to play in our future, not just our own generation, but intergenerationals for thousands of years ahead of us. Joshu, what a massive thing to have on your shoulders.
Yeah, I totally see it as a future thing. It's something that in 50 years' time, it's going to be just absolutely critical to understand this. And at the moment, we're just sort of getting an idea of what's there and even just seeing the need for it.
Literally scratching the surface of what's underneath. Absolutely incredible. Thank you so much for your time, Joshu, Dr. Joshu Mountjoy, a marine geologist at NIWA. Oh, I'm sorry. I'm just absolutely blown away by how much we just don't know. And of course, what we do know, you can find in Farmers Weekly and farmersweekly.co.nz. And thank you so much again to Richard Rennie for that story.